As Australia appears to be experiencing increasingly severe cycles of drought, fires and floods, other parts of the world, such as Southeast Asia, are also facing more extreme weather and increasingly serious flooding. This extreme weather wreaks havoc both in economic terms and in human suffering. Increasingly severe weather is a problem that both urban and rural communities have to devote more time, planning and resources to try to manage and mitigate. Unfortunately, this is a problem that's unlikely to go away soon. For example, in Sarawak, eastern Malaysia, scientific modelling of the Rajang Delta has demonstrated that flooding is likely to become more widespread, disruptive and destructive. To address this problem, for a number of years, local government has been investing in water infrastructure to better manage flooding and irrigation. The government began planning construction of a canal and levee network covering about 60 kilometres in length. Located in Betong district, the project was intended to better handle the region's year-round rainfall, which increasingly turned into floods. Initial estimates calculated that the project would take 4 years to complete and required significant volumes of building materials to complete the project. The weather over Borneo dumps an astonishing 3,300 millimetres of rain throughout the year on Sarawak, with 350 millimetres just in October. In addition to the constant rain and a tight budget, the project faced the problem of lacking a suitable local aggregate supply for conventional concrete construction. The government and the contractor identified DuraCrete, a cement additive, as the best option to meet the project's challenges and requirements. Construction of the 60-kilometre canal and levee network was initially scoped to take 4 years to complete. Also known internationally as EvoCrete, DuraCrete cement additive was developed in Germany in the mid-1990s by Shamrock Geoscience. Since then, it has been improved and successfully applied on over 4,000 projects worldwide. No longer requiring aggregate for concrete, soil tests showed the project required only a mix of 9% cement and 2% DuraCrete, combined with the in-situ soil. The DuraCrete cement and soil were combined on site. Water was added and the ready-made mix was transferred to the canal. For most projects, such as road base or foundations, the conventional approach would be to add water to start the curing process, after the materials had been mixed, levelled and rolled. But the flexibility of the DuraCrete means for projects such as this, water can also be added during mixing. Then the wet mix laid onto the site and rolled. The first stage was laying the base with an excavator. The base was then levelled and compacted. Our consultants worked closely with local engineers and crew to ensure success and knowledge transfer. Correctly laying the base was crucial to seal the canal and prevent seepage and leaks. The DuraCrete approach meant that construction could be undertaken using relatively simple machinery: dump trucks, a recycler, an excavator, and simple compactors. The next step was the canal walls. Each side of the embankment was compacted with a small tandem steel wheel vibrating roller. The last step was profiling the canal walls with an excavator bucket. Core samples were drilled within 24 hours of laying the base. Lab tests of the cores revealed high tensile and bearing strength, as well as very low water permeability. Less than 2 days after the canal was laid, it was in operation. Clear water flowing over the stabilised canal. After a decade of diverting and managing the runoff of torrential rainfall, the canal system is still solid and dependable, protecting both the community and the Sarawak's food bowl agriculture sector. By utilising DuraCrete as the cement additive, the contractor was able to complete the 60-kilometre canal in less than a third of the original 4-year schedule, reducing costs by 30%, slashing material requirements, and cutting environmental impact. Build construction of crucial water infrastructure, where conventional building methods and materials would have been financially prohibitive, creating a safer environment for the community and the farming sector, delivering a triple bottom line benefit: financially, environmentally, and socially.